Marine mechanics with 25 and 30 years of experience are quietly buying 1990s outboards for their own personal boats, while the customers in their shops pay over $30,000 for brand new four-strokes. The pattern is not anecdotal. Walk into any commercial marine shop in the Gulf Coast, in the Florida Keys, or along the Pacific Northwest, and the personal boats parked behind the workshop will almost always have a Yamaha, Mercury, or Suzuki built between 1996 and 2003 mounted on the transom. These are not nostalgia choices. They're calculated decisions by the same people who fix outboards for a living and who have access to the diagnostic tools, the warranty data, and the parts pipeline that customers never see. There are 5 specific reasons mechanics make this decision for their own boats, and once you understand what they know, buying a new outboard in 2026 may turn out to be one of the worst financial decisions a boat owner can make right now. This is what the dealers will never tell you. A modern Yamaha F250 outboard will not start after a battery disconnect without dealer-level reauthorization. The same engine cannot have its ECU read, its fault codes cleared, or its fuel injectors recalibrated without the Yamaha diagnostic system. The tool costs around $3,000 for the hardware and runs on an annual software subscription that only authorized dealers maintain. A 1998 Yamaha 200 horsepower two-stroke has none of this. The engine uses a point-style ignition. The fuel delivery is mechanical, through carburetors. Any competent mechanic can trace the wiring harness with a multimeter and a service manual. The 1998 engine will start after a battery disconnect because nothing inside it requires authorization to operate. The diagnostic dependency extends well beyond fault code reading. A new Mercury 200 four-stroke being repowered after cylinder damage needs the same physical work as the older engine, plus a dealer authorization to write the new powerhead serial number into the boat's central electronics. Without that authorization, the engine will not run. The mechanic doing the repower of his own boat skips every step of that process by choosing an engine that does not require it. The independence is the entire point of the decision. Marine technician forums on iBoats and The Hull Truth have documented the same pattern in dozens of threads going back over a decade. Working mechanics who post about their personal boats overwhelmingly run engines from the late 1990s and early 2000s. The reasons given are consistent across regions, age groups, and brands worked on. The 1999 Yamaha 200 horsepower two-stroke shows up on personal boats across every market where commercial mechanics operate. And the engine choice traces directly to the diagnostic problem the new outboards introduced. Parts pricing tells the next part of the story. A complete water pump rebuild kit for a 1998 Yamaha 200 horsepower two-stroke costs in the range of $40 to $50 through aftermarket parts suppliers. The equivalent kit for a 2024 Yamaha F250 runs over $200 when purchased through the dealer network. An impeller change every 2 seasons on the older engine is a 15-minute job at a $40 parts cost. The same maintenance on a modern engine runs 4 times higher in materials alone before labor is even calculated. The parts pipeline behind the older engines is more diverse than most boat owners realize. A 1998 Yamaha 200 horsepower uses standard bearings and seals that remain in production from multiple aftermarket suppliers. Online parts vendors carry full inventories at prices below dealer levels. A 2024 Yamaha F250 uses proprietary fuel injectors that only the dealer can source, plus ECU components that the dealer controls through software interface. The replacement cost difference on a single engine over a 15-year ownership cycle runs into thousands of dollars even on a well-maintained engine that never has a major failure. The power economics extend the same logic. A 1998 Yamaha 200 horsepower two-stroke that needs a powerhead rebuild can be refreshed for around $4,500 at most independent marine shops. A 2024 Yamaha F250 that suffers a similar internal failure typically requires a complete powerhead replacement at a parts cost between $15,000 and $18,000. The dealer-level authorization charges for serial number reprogramming add another expense layer on top. A mechanic who can rebuild the older engine for a fifth of the cost has every reason to keep doing exactly that. Saltwater is the environment that defines outboard service life. The corrosion resistance built into a 1996 Yamaha cylinder head is measurably different from what is in a 2024 model. The older engines used heavier aluminum castings, thicker walls on critical components, and bronze water pump housings that resist galvanic corrosion. The modern engines use lighter aluminum alloys engineered for weight reduction. The thinner casting walls save weight but reduce service life in saltwater environments. The documented examples support the engineering difference. Commercial fishermen working out of Bahamian harbors have logged over 3,000 operating hours on original Powerhead 1996 to 2003 Yamaha two-strokes without major rebuild work. The same operating profile on a modern four-stroke typically requires major service intervention at 1,000 to 1,500 hours. The failures show up as corrosion in cooling passages, fuel system degradation, or electronic sensor problems. These hour counts come from commercial fleet maintenance logs that mechanics see through professional networks, and that retail buyers rarely access. The structural reason behind the durability gap traces back to manufacturing priorities. Engineers building outboards in the 1990s designed primarily for service life. The 2020s engines optimize for emissions compliance and fuel efficiency. Service life is now engineered to match the warranty period of 3 to 7 years depending on the manufacturer. A mechanic who plans to keep a personal boat for 15 or 20 years is making a different calculation than a marketing team designing an engine to meet warranty obligations and then transition the customer into the dealer service revenue stream. The warranty constraints on new outboards are not always obvious until something fails. Yamaha, Mercury, and the other major manufacturers reserve the right to void warranty coverage when maintenance is performed outside the dealer network without proper documentation. Aftermarket parts installed in place of OEM components trigger the same risk. A boat owner who chose to save money on a routine service by going to an independent shop can find, 2 years later, that a failed sensor is not covered because the service records show non-dealer maintenance somewhere in the engine's history. A mechanic who owns a 1998 Yamaha has none of these dependencies. The engine carries no warranty. The mechanic services it himself, sources parts wherever the price is lowest, and repairs it in his own driveway. The dealer relationship that locks new engine owners into a specific service pathway does not exist for the older engine. This is the operational logic that pushes working mechanics toward used engines for their own boats. The dependency extends to insurance coverage on new engines. Marine insurance policies on new outboards typically require dealer-level service documentation as a condition of coverage. A failure during the warranty period that traces back to undocumented service can be denied by both the manufacturer and the insurer. The boat owner ends up with no coverage on either side. A used 1998 engine outside warranty has no such requirement, and the mechanic who owns one can take the boat anywhere without affecting the insurance terms at all. The financial math is the calculation most boat owners never run for themselves. A new Yamaha F250 four-stroke retails for approximately $33,000 in 2026. A clean, well-maintained 1998 Yamaha 200 horsepower two-stroke with documented service history sells in the used market for between $3,000 and $5,000 depending on hours and condition. The price difference is roughly $28,000 on the engine alone. That money funds the entire fuel budget on a typical recreational boat for 10 years. The depreciation curve makes the math even more lopsided. A new outboard loses approximately 30% of its value in the first 3 years of ownership. The 1998 outboard already lost its depreciation over the past 25 years and has reached its asymptotic value. A buyer purchasing one in 2026 will likely sell it for nearly the same price 5 or 10 years later if maintenance stays current. The new engine buyer is paying $30,000 to lose $9,000 to $10,000 in value over the first 3 years, before they even begin to accumulate fuel and maintenance costs. The risk math closes the case. A used engine purchased for $4,000 has a total replacement exposure of $4,000 if catastrophic failure occurs. The buyer can treat the engine as financially disposable in worst-case scenarios. A new engine purchased for $30,000 carries 7 times the catastrophic exposure with only warranty coverage as mitigation. And that coverage requires dealer-managed service and expires within 5 years. The mechanic running this calculation reaches the same conclusion every time. The old engine is the better financial decision before any sentimental factor enters the analysis. The maintenance practices mechanics use on their personal 1990s engines are different from what most boat owners do. And the differences explain why those engines accumulate 3,000 and 4,000 hours without major rebuild work. The first practice is the saltwater flush. Every time a mechanic-owned boat comes off saltwater, the engine gets a full freshwater flush through the muffs at idle for at least 10 minutes. Not the 2 minutes most owners do. 10 minutes minimum, with the flush water running clear before the engine is shut down. Saltwater left inside the cooling passages is the single largest cause of premature outboard failure, and mechanics who own old engines treat this step as non-negotiable. The second practice is the oil ratio on two-stroke engines. Most owners run the manufacturer-recommended 51 fuel-to-oil ratio. Mechanics with higher-hour 1990s two-strokes typically run 41 with commercial-grade marine two-stroke oil. The extra lubrication adds almost nothing to fuel consumption but extends the service life of cylinder walls, bearings, and crank seals significantly. The trade-off is slightly more carbon buildup, which mechanics manage with periodic decarbonization treatments using products like Yamaha Ring-Free or Mercury Power Tune. The third practice is the lower unit oil change. Modern boat owners change their lower unit oil once a season. Mechanics with personal 1990s engines change it twice a year minimum, and they pull the lower unit completely off the boat every 3 to 4 years to inspect the drive shaft splines, replace the impeller, and clean the water pump housing. The lower unit on a 1998 Yamaha will outlast the boat itself when maintained this way. Most owners never see the inside of theirs until something has already failed. The fourth practice is fuel system management. The 1990s engines do not have fuel injectors and ECUs that compensate for ethanol-contaminated gasoline the way modern systems do. Mechanics who own these engines either run non-ethanol fuel exclusively or treat every tank with a marine-grade ethanol stabilizer. The carburetors get rebuilt every 3 to 5 years on a preventive schedule, not on a failure schedule. A rebuilt carburetor kit costs around $80 in parts. The labor takes about 3 hours per carburetor body for someone who knows the work. A fuel system kept on a preventive schedule never strands a boat offshore, which is the entire reason mechanics own these engines. The repower trend is accelerating. Independent marine shops across Florida, Texas, and the Carolinas have started reporting that rebuilt 1990s outboards now make up over half their annual engine sales. 5 years ago, that figure sat below 20%. The shift is being driven by boat owners who finally ran the numbers themselves, and the supply of clean 1990s engines available in good running condition is starting to tighten. A used Yamaha OX66 250 that sold for $2,500 in 2020 now sells for $4,000 to $5,000 in 2026, and the trajectory points upward. The mechanics who bought theirs 10 years ago are sitting on appreciating assets, while the new four-stroke buyers next door are eating depreciation. The math will continue working in favor of the older engines until the supply runs out, and based on current repower demand, that point may arrive within the next 4 to 5